the idea was driven mostly by fun. How much fun can we have? But it was also driven by big needs, big global needs. After the typhoon in the Philippines and the news reports that kept coming out about communication. How do we communicate? There's lines are down, there's no access. So this tree suddenly became this communication hub. A solar-powered, pedal-powered, cell phone charging station. It's also a broadcast PA system, a public address system. So you can plug in a microphone and talk through, and communicate big messages. So the project itself, again, started with a fun, quirky thing for students in one school, and then quickly evolved into a global impact and what was possible. So using the design process we break our design, we'll talk a lot about this in our lab as well, but our design process we've reduced to 3 steps: discover, design, and then deliver. Because when you look at Stanford and you look at all the organizations, Frog Design, the steps are complicated. They become checklists for students and teachers, and it eliminates all innovation. When innovation becomes a worksheet, you're in trouble, right? So then you're not innovating anything. So we kind of turned that on its head. It really started with what was approachable for students. And most of that is fun. You're going to see some of this stuff in the shop as well. But this tree represents that, discovering both the electrical issues, right? So solar electrical engineering is fairly complex. Pedal power, generating, from mechanical energy with variables, pretty complex for 14-year-olds and 16-year-olds. So we've had one team working just on the pedal power, another team working exclusively on the solar electrical. Then we needed a team entirely on the structural issues. So you guys can come around too and see the backside. But this is a basketball from someone's yard, from the garage or the driveway. So what we did was we knew structurally it was sound enough to hold a lot of weight, top heavy weight. So we borrowed one from someone's backyard and stripped it down to its components so that pole that holds the backboard is still there. Yeah. And so the tree was kind of built around that structural issue. And that took a lot of tinkering and constant iterations. You'll see some prototypes in the shop. And then all of the guts here, really just, it's a matter of, we'll start connecting things here. It's a matter of, this we went for, our seniors recently left. They just got out of school. And so we decided to go for functional, not finished. And so what you're seeing is the functional aspect. One more wire here. And then what we're doing now in the ultimate iterations will be doing all this finish work so that kids can... Yeah, there we go. The top ones are good. And so... you want to hop on? We'll do our... So combining pedal power and solar, fairly complex. Oh, here's our solar engineer, Kerry. So Kerry took the lead on breaking through all of the roadblocks. Every time there was a dead end, Kerry figured out a way to engineer around it, which is really engineering and design at its finest, right? Workarounds. So Eleanor's going to crank this up. So what we're doing is we're looking for a minimum amount of voltage. Yep. That's a capacitor. So one of the cool things about our innovation lab is we're I don't know if you guys knew the show MacGyver.
Yeah.
Some folks.
Love it.
Yeah, great show, right? So that's what we do down in green engineering and the innovation lab. The idea is constraints are your best friend, right? So if you can find freedom in constraints, there's really nothing that can hold you back. So we find parts and pieces and engineer from found materials.
And do your daily bit of exercise.
And get some exercise in too, yeah. So we'll do a little...
Our last day for seniors, they do a thing called countdown where they count down their last few minutes.
Yeah.
Did you say this already?
No.
And I was on the bike while their music was blasting. It was quite fun as a principal to be pedaling for their last few minutes. So pretty exciting. You can't go too fast. I learned if you go too fast, you're in trouble.
No, you got it. You got it.
You got to get the, I know, yeah, a certain thing. So it's there you go. What are you gonna play, Mr. Chinosi?
It's actually, oh, there we go. Too high, too high. Some of these singers are Danes. This is an album called Playing for Change, and they found street musicians all over the world and put them together in a soundtrack. And now they build schools all over the world to teach music education, but also empower kids. And this is Clarence Decker. He's a Danish singer. Is that your family? Yeah. Is it?
That's his family.
But so we can replace the music with a microphone and give speeches. We can also bypass the pedal and go right to solar. For us, the kids, again, starting with this real tangible effect for kids. Kids, it's hard to process global change when you're 15 years old in Newton, Massachusetts. But if you create something that is a bridge to something global, then you'll see real change, real innovative work. Thanks, Eleanor. No, that's okay.
All right, should we go see some stairs and then we'll come on? Wait.
Yeah, we got
all right,
the
here we
wind
go.
sound. Oh, wow.
Here we go.
Vince, explain your
Here we go.
concept there.
This just arrived, right?
Yeah.
Yeah,
Yeah.
the file components to attach it.
Yeah.
Yes.
So this is one of our major projects in engineering street and all that way. And we decided at the beginning of the year as a group that one of our projects was to make a land surfer like this. And it seemed like we were doing some mountable tasks first, all these different components coming together. So the third of the class split into further smaller groups, and I was involved primarily with working on this sail here, which we made in the engineering lab using air sewing machines. And some of our seniors who are gone now worked on the board here and the assembly of the blocks and the wheels. And some mast and this final component came in from the Canadian company being several months ago. It finally came in this week. So it's all coming together. And the last component we have before we can actually test this on the track out there is a handlebar, which we're going to create from aluminum rods which we bend around and attach to blocks here on the mast and at the end of the sail over there, right below the boom in this section here.
So every aspect of this was designed by students, from the board to the sail,
Rosie here,
and
Amazing.
constructed by the students.
Amazing.
Isn't that something?
all the calculations and all.
Vince did a lot of the sewing on this.
Yeah.